All right, today we're pulling back the curtain on AI, but we're not just going to look at the cool magic tricks, right? We're going backstage. We're going to meet the magician and see the incredible, hidden machinery that makes the whole show possible.
Think about it for a second. You type a few words into an AI image generator, and boom, a masterpiece appears in seconds. It totally feels like magic, doesn't it? But, it's not. What's really happening is this incredibly complex, kind of beautiful technical symphony. And today, we're going to meet the two lead players in that orchestra.
So, on one hand, you've got the brains. That's the machine learning model. Think of it as the artist, the creative genius who actually knows how to paint the picture. And then on the other hand, you have the brawn. That's the Kubernetes infrastructure. This is the entire backstage crew, the roadies, the logistics team. Heck, it's the whole concert hall, making sure that one artist can perform for millions of people all at the same time without a single hitch.
Okay, so to really get a handle on this, let's start with the brains of the operation. Let's put the artist in the spotlight. What exactly is a machine learning model?
Well, at its heart, machine learning is pretty much exactly what it sounds like. It's a machine, learning. It's all about sifting through tons of past data to find patterns. Just like how we learn from experience, a model gets trained on, say, millions of images and their text descriptions. It does this over and over until it develops this kind of intuition for how to create its own stuff from scratch.
And it turns out these models can learn in a couple of main ways. First, there's supervised learning. This is like giving the AI a giant stack of flashcards with the answers on the back. It's studying for a test with an answer key. But then you've got unsupervised learning, which is way more figure it out yourself. It's like we just dump a huge mixed bag of fruit on the table and say, okay, sort this into groups that make sense. The AI has to discover the patterns all on its own.
Okay, but here's the catch. This is the really crucial point. You could create the most brilliant, most creative AI model in the entire world, right there on your laptop. But if it's stuck on that one computer, it's basically useless to everyone else. It's a genius trapped in a bottle. It can't possibly handle requests from millions of people all over the planet. And that brings us to the next massive challenge.
Right, the challenge of scale. How in the world do you take that one brilliant model and let it perform for the entire planet simultaneously without ever missing a beat?
This is the real-world gauntlet every single major AI service has to run. Seriously, what happens when 1 million people want an image at the exact same second? What do you do if one of the thousands of servers just dies? How do you roll out a new, smarter version of the AI without taking the whole thing offline for maintenance? Yeah, you have to solve all of these problems, all at once. So the answer to all that chaos, the brawn that wrangles this whole global-scale operation, is a system called Kubernetes. Honestly, this thing is the unsung hero of the modern internet.
And the best way to picture what it does is to go back to our orchestra. See, Kubernetes doesn't play an instrument. It doesn't generate the art. That's still the model's job. No, Kubernetes is the conductor. It's the one telling thousands of different computers what to do, when to do it, and how to work together in perfect harmony to put on a flawless show for the audience, which, of course, is all of us.
So how does this actually work? How do we put the brains and the brawn together? How do the scientists who build these incredible models hand them over to the system that shares them with the world?
It's actually a pretty elegant process. So first, you take the machine learning model, the brains, and you package it up, kind of like putting the star musician on the tour bus. Then, an engineer writes a set of instructions. This is the sheet music. It tells Kubernetes exactly what to do with the artist. How many clones of them we need, how to handle the massive crowds, all that stuff. And finally, step 3. The conductor, Kubernetes, just takes that sheet music and runs the whole show, automatically. And this is where it gets really, really cool. Using just a few simple commands, an engineer can literally act like a conductor. They can just ask, hey, how are all my musicians doing? Or they can shout, we need more power, add more violins for the big crescendo. And what's just mind-blowing is they can swap out the entire piece of music for a brand new one right in the middle of the performance. And the audience, you and me, we'd never even notice a hiccup.
Okay, so let's zoom out. Why does any of this invisible engine stuff matter to you? Well, because this partnership, this dance between the brains and the brawn, is the fundamental engine that's driving the entire AI revolution.
The biggest thing to remember is this: intelligence needs orchestration to actually have an impact. A brilliant idea is kind of powerless if you can't share it. The brains give us the amazing what, but it's the brawn that gives us the powerful logistical how. And to change the world, you absolutely, positively need both. And that leaves us with a pretty fascinating, maybe even a little spooky, final thought. Right now, humans are the conductors. We're the ones writing the sheet music for systems like Kubernetes. But as AI gets smarter and more autonomous, who or what is going to be the conductor then? That's a question that's probably going to define the next decade of tech. Thanks for joining me on this one.